Episode 2: How AI Models Work and How to Choose and Deploy Them. In this episode, how generative models work, picking a model by capability, deployment options, and the configuration parameters you tune. This episode covers the second slice of Domain 1, the components and configuration of AI models. Let us begin with how a generative AI model actually works, because once that clicks, the parameters make sense instead of being magic dials. A large language model is, at heart, a next token predictor. Text is broken into tokens, roughly word fragments. The model has been trained on a vast amount of text and has learned the statistical patterns of which token tends to follow which. When you give it a prompt, it predicts the most likely next token, adds it, and repeats, one token at a time, until it has produced a full response. Under the hood, it represents meaning as embeddings, numerical vectors where similar concepts sit close together, and it uses a transformer architecture with an attention mechanism to weigh which earlier words matter most for the next prediction. You do not need the maths for AI-901. You need the shape, tokens in, learn patterns, next token prediction out. 2 more shape words. Pretraining is the big, general learning phase on broad data. Fine-tuning is an optional extra phase where you nudge a base model on your own narrower examples so it specializes. And the context window is the amount of text, prompt plus response, the model can consider at once. If you exceed it, the earliest content falls out of view. Choosing a model by capability. AI-901 wants you to match a need to a model type. In the Microsoft Foundry model catalog, you will meet several families. Chat or completion models, like the GPT family, generate and reason over text. They are your default for conversation, drafting, and summarizing. Embedding models do not chat, they turn text into those vectors, which is what powers search and retrieval. Image generation models, such as the Dolly family, create pictures from a text description. Multimodal models accept more than just text, they can take images, and increasingly audio, alongside text in the same prompt. And there are dedicated speech and vision models for transcription, synthesis, and image analysis. The exam skill is recognizing, from a scenario, which family fits, need a picture from words, that is image generation, need to power a semantic search, that is embeddings, need to answer questions about an uploaded photo, that is a multimodal model. Deployment options. Picking a model is step 1, deploying it is step 2. In Foundry, you deploy a model to get an endpoint you can call. You will hear about a couple of consumption styles. Standard, pay-as-you-go or serverless deployments bill you per token used and are perfect for variable or early-stage workloads. Provision throughput reserves dedicated capacity for steady, high-volume, latency-sensitive production traffic. You also choose a region, and you should be aware that not every model is available in every region. For the exam, hold the trade-off, serverless and paper token for flexibility and low commitment, provision throughput for predictable scale. Configuration parameters. Finally, the dials you set when you call a model. Temperature controls randomness, low temperature, near zero, makes output focused and deterministic, good for factual or code tasks, high temperature makes it more varied and creative. Top P, also called nucleus sampling, is a related way to control randomness by limiting the pool of candidate tokens. You generally adjust temperature or top P, not both hard at once. Max tokens caps how long the response can be. Frequency and presence penalties discourage the model from repeating itself. And stop sequences let you define text that, when generated, tells the model to halt. The headline you must keep: temperature is the creativity versus consistency dial. Turn it down for reliable, repeatable answers, turn it up for varied, creative ones. Quick recall. Large language models are next token predictors, tokens in, transformer and attention, prediction out, meaning stored as embeddings. Pretraining is broad learning, fine-tuning is optional specialization, the context window is how much text fits at once. Model families. Chat or completion, embeddings for vectors and search, image generation, multimodal, speech and vision. Deployment, serverless, or pay-as-you-go, For flexibility, provision throughput for steady high volume, region matters. Parameters, temperature and top P control randomness, max tokens controls length, penalties reduce repetition, stop sequences halt output. Say it back. Pause after each question, answer out loud, then play on. You need consistent, factual answers from a model. Raise or lower temperature. Lower it towards 0 for focused, deterministic output. Which model family powers semantic search, and what does it output? Embedding models. They output numerical vectors that capture meaning. A production app has steady, high volume, latency-sensitive traffic. Which deployment style? Provision throughput. Reserved, dedicated capacity. What is the context window? The amount of text, prompt plus response, the model can consider at once.